like cardio text, 2 minutes less, boom, done. Which is not correct, right? That's not correct. That ignores the whole idea of the interval that's right here. Jamie, go.
Plus the sample size is 38.
Which makes you
Leery of the results at all.
totally fine. Jamie brings up a very, very good point that is not at all intuitively obvious. When you're measuring averages versus proportions, you need far fewer data points to get smaller margins of error. I love what you just said. More data, assuming the data is good, is always better. Assuming that your data is randomly selected, indicative of your population, more data is always better. Because what's more data going to do, friends?
Make it smaller.
Yeah, more data is going to take these tanks, and with one assumption, which may or may not be correct to say, if we recalculate these intervals with more data, assuming x bar stays directly where x bar is now, these intervals are going to start shrinking down. And eventually, if your sample sizes get large enough, what will happen to those two intervals, assuming x bar stays exactly where it is? Darla, what's going to happen to them? They're going to line up, and then eventually, what are they not going to do anymore? If the sample sizes get large enough, number one, and x bar in each one stays exactly where it is, what's going to happen as these things get smaller and smaller and smaller? Eventually, they won't. Jamie, go ahead. Oh, good, the bar is going to get taller, but the intervals themselves are not going to overlap, which means there will be a statistically significant difference. That's why I keep saying statistically significant. That means the intervals are not overlapping with each other, which is the homework question, or the exam question on the take-home, right? The analysis of that statement. I'm not talking about what I refer to as practical significance. We never talk about this in this class. Because practical significance implies you have to know something about the context of every single possible contextual idea. So you have to know, well, it's two minutes less per week, or per day, whatever it is. Is that significant? I don't know. Is it practically? I don't know. Statistically, it's not. There's no difference at all here statistically. Practically, I don't know. Let's let other people argue about that. This makes it more black and white, is what I'm trying to say here. This makes it a lot more black and white for you guys. You can look at it and say, they don't overlap, therefore I can't make a call. Excuse me, I said that backwards. They do overlap, therefore I can't make a call. Sorry. Susie?
Because there's reasonable doubt.
Reasonable doubt, basically. There's a doubt that this is actually lower than this one. I like checking it though, and it comes back, you have a great question. I feel bad throwing outliers out. Totally fine. In this case, including them or not including them doesn't change anything. But I still saw, when I drew that quick little bell curve over there, and I wish the TI had what's called a normal overlay, which means to draw in basically the curve I did. There are other kinds of tools, we'll learn them as we go through the class, to test for those assumptions. But really, the big thing that you guys will be responsible for on the exams is crunching these guys right here, and then deciding if there's any statistically significant difference between these two ratios. So testing for assumptions, I'm not going to ask you to do it. Not going to ask you to do it. Explaining why no overlap implies no statistical significance, I'm going to ask you to do it one time on a take-home that's due on Tuesday. Because I want to keep using the fish analogy. I want to keep using the word overlap. I do. I love them. But I want to make sure that we don't lose the meaning of all those ideas. Because they don't just mean overlap. There's a reason overlap means. And the idea, the big idea, I'll give you a hand in answering it. Since these guys overlap, it's possible that the parameter in the interval that appears to be lower is actually higher than the parameter in the interval that appears to be higher. Does that make sense? So in other words, if you look at this, yes, on average, I'm using average, and I don't know what context I'm using average right now. On average, a data point, percentage-wise, as a percentage, the points here are lower than the points here. Okay, whatever how you want to define that, ignoring the distributions. However, it's still possible that whatever parameter you're studying in this one is at the far upper side of this interval, and this one's at the far lower side. Which means even though it looks like the top one's lower than the bottom one, it could be vice versa. They could be the same, for that matter. They could be the same, for that matter. It's inconclusive. You can't make a call based on overlapping confidence intervals because you don't know which parameter is above the other one. When they don't overlap, it's perfectly clear when they don't overlap. Because the lower interval, even the highest value, is still less than the
lowest value in the upper interval. Boom! That's paraphrase that somehow, and that's the answer to that question from your take. I mean, honestly, that's basically the answer. Paraphrase that somehow. Commit that to the back of your mind. So when we talk about the word overlap versus non-overlap, we actually have a concrete backbone for that. Yeah, Jamie.
I know this is a little behind where I realize it might be big. Parameter, the whole parameter idea is a little blurry for me.
What is a parameter a measure of?
Of the population. So my question, just to kind of see if I'm getting it, is that the statistic is the whole bar and the parameter is the fish.
The parameter is the fish, yes. The statistic is not the whole bar.
Okay.
The statistic is the middle of the bar. What's the whole bar? The statistic plus or minus its margin of error. So the statistic is always in the middle of these bars, always. That's how you form them. You start in the middle and you add and subtract the margin of error to create the tank. And like you said, as the sample size gets larger, the tank's going to shrink down because your standard error shrinks. Fair enough? So yes, fish parameter, absolutely. Fish parameter, yes. Middle of the tank, statistic. Plus or minus the margin of error to create the tank. Cool, awesome. These are good things to repeat. These are good things to say again. Very, very good things to say again. It gives us a nice logical place to head next, which we'll do after the break today. Good? That was a fantastic exam review question, by the way. And I shouldn't say, not the normality part. Not the normality part. I'm not going to ask you to do that because it's too gray for an in-class exam, for sure. If I say test of normality, you're like, wait a minute, it looks Bell to me. And then that drives students nuts on an in-class assessment. Wait a minute. But Bob's going to say something different. I don't like giving exam questions like that because it makes you guys second guess yourselves. I like giving you a data set and saying, form an interval, or two in this case, form two. Is there a difference between these two intervals? No, because the overlap. That's perfect, like 1, 2, 3, like 1, A, B, and C. Here's an interval for this, interval for this. Is there a difference? Boom. Cool? Let's over-answer it again. Let's over-answer it again. Suppose we're testing some other group of people. Suppose these cardio techs were being tested from Colorado, just for the hell of it. And then we tested another random sample from Pennsylvania. And we are told, without any, I shouldn't say we tested, we have a figure given to us that the average workout time of a PA, Pennsylvania, cardio tech is 35 minutes per week. 35 minutes per week.
But are they the same altitude?
Apples. Apples, apples. No, they're not. No way, nowhere near. But don't worry about that. All we're trying to see is, this is workout minutes per week. Workout minutes per week. And let's ignore the outlier data set just to keep things simple. Okay, let's take out without the outliers. Just look at the normal full data set of 40. Can we conclude with 95% confidence, that on average, PA cardio techs work out less, fewer minutes per week than Colorado cardio techs? With 95% confidence. We have to. Because what did they report to us? That mu was 35 minutes a week. Does this have a margin of error? No, they called it mu, didn't they? They called it mu. Since they called it mu, that doesn't have a margin of error. I mean, it probably does, but they didn't give it to us, and we have no way of getting it. So if all they're telling you is, on average, a Pennsylvania cardio tech works out 35 minutes a week, you say, well, that means Colorados work at least 10 minutes a week. Coloradans work at least 10 more minutes, at least 10 more minutes a week than Pennsylvanian cardio techs.
And they do it at altitude, so it matters.
What? Again, statistical significance, not practical. Statistical versus practical. Not worrying about the practicality of it, just numerically, purely numerically. This is exactly why I don't want to get into the practical aspects of it. Suppose we're now talking about British Columbia.
Canucks.
The Canucks. Yes. British Columbia cardio techs. We are told they average 55 minutes per week of workout time. We are told that. We are not given a margin of error at all. We're just told that its average is 55 minutes a week. Can we claim that there's a difference between the average amount of time that BC cardio techs work out and Colorado cardio techs work out? We can't make a claim anyway. It's inconclusive. How come? I'm sorry, I heard a lot of really good answers. Help me out, Gary. Get in there. I have to look up and see your mouth moving. Go ahead.
I said it was in the tank.
In the tank. It is in the tank. And what does that mean if it's in the tank? In the tank is fine. In the tank is totally fine. But I want to verbalize it, especially because I like the fact that we have this right here and you can refer back to it. What does it mean that the fishy's in the tank? There's an overlap, which means that what are the three possibilities if this is in the tank for Colorado? Either Colorado cardiotechs work out more or less or the same. Because 55 basically sits right here, it's possible that Colorado cardiotechs work out down here. The fishy could be down there, the parameter could be down there. It's possible it's up here, and it's possible that it's right there. So it's inconclusive. You can't make a call. You can't make a call. Fair enough? Believable? Good. What if they told you, let's go back to BC cardiotechs. This is getting a little bit over and above, but I kind of believe in training with swinging the two bats mentality. Suppose they say we did a study. We did a study. And in the study, I have no idea what the sample size was. I'm not going to tell you anyway. 55 minutes per week, BC, X bar. What do you think? Is there a difference between the amount that cardiotechs work out in BC versus the amount that cardiotechs work out in Colorado? If all they tell you is that they didn't give you a margin of error, but you know there is one now. But you know there is one now.
There is not a statistical difference between the two.
There still isn't, is there? There still isn't, is there? Because you still have to accept this. You still have to accept this from Colorado. And all you know now is, here's BC. Here's X bar for BC. The margin of error, whatever it is going to be built off of that. Jamie, back to your point. The tank around BC's exercise time is going to be built around this X bar. So the tank is going to go like this. But you're seeing what happens. No matter how small or large you draw the tank, it's going to overlap this tank, which means you can't make a call. Is that believable? No matter how wide or how narrow that tank is, it's going to be at least partially contained in the tank for Colorado, which means you can't tell them apart. One could be larger, one could be smaller. They could be exactly the same again. Susie, go ahead.
What is the difference between using X bar and BC?
That's a great question. What is the difference when I say X bar versus mu? Who wants to answer that question? It's a fantastic one. Mary, go, my friend.
X bar is when you take a sample, and mu is when you have the entire population.
X bar is the average of the sample. It's a purely descriptive statistic. Theoretically, mu should be a descriptive statistic too, but there's no way of knowing what mu is without actually asking every single member of the population. Is that fair, Susie? It's a throwback question in 243.
So the mu is the average of the entire population. And
Yes.
X bar is the average of the sample.
Yes, and what's the problem with putting X bar by itself? There's no sample error, which you have to include with a study. That's the problem. That's the problem. So I'd like to go back with one more question, if that's okay. I love this question, Lena. I hate that. It's a bummer that we're taking it so long, but it's also not a bummer because this is exactly like, this is the whole course wrapped up in like one problem. Let's do X bar of the workout times, for, let's go back to our PA friends, to our PA cardiotechs. And I think we call that 35 minutes, right? 35 minutes per whatever. I think it was week. We can see all this in the camera, right? This will be a good, yeah. Okay, I gotta make this a little bit. So here's PA. Bar PA. What do you think? No margin of error given, of course, because this is mass media. You can't tweet a margin of error. It takes too many characters. It's still inconclusive, isn't it? It's still inconclusive, but it's more frustrating. Because if I use a similar margin of error to the one I used over here, it might be conclusive. Right? If I use a similar margin of error, what is that margin of error? What is the margin of error on this study right here, friends? You got it already, Ian? 17. How did you figure it out, my friend?
62 minus 45.
Exactly. Oh, so careful. 62 minus 45, 17. The margin of error is actually half of that, right? So, no, you got it, man. 8.5. Beautiful. 8.5 8.5 minutes. Everybody catch that? That slight difference? The interval is spread 17 minutes. But the margin of error is only half of that because, as Jamie said, you build the interval off the middle. So you add a margin of error and subtract it. So 8.5 minutes. So if I add 8.5 minutes to 35, I go to what, 43.5? Which actually brings me right up to there. So assuming, big assumption here, assuming the margin of error for this study is the same as it was for the Colorado study, is there a difference, statistically significant difference in workout times?
Yes.
Yes, because they don't overlap. Now, you might argue that 1.5 minutes, no, there's a minimum difference of 1.5 minutes. But that's still a difference. That's a statistically significantly measurable difference. But I made a big assumption, right? The big assumption was that the margin of error is the same. But you know what, guys? You have to do that from time to time because they don't give it to you. So you have to say, what can I get from this data? Can I get anything? Suppose the margin of error was actually 17 minutes, like Ian said. So it's double the margin of error. Say the sample size was 1/4. So it's double the margin of error. Okay? Then you have no idea what was going on. They'd be totally overlapping each other. You're starting to see like the problem with mass media and how it reports statistics? Yeah, they hide the most important part very often. Very, very often. The most important part, the margin of error, is nowhere to be seen. So you can't make a call about it if you don't see that. Alina, this is a great question. This is a great question. You've actually answered like half of your exam on Thursday in this question. Well, not really, I didn't use this data set, but questions just like that. And you got a freaking video of it, which is even better. Go back and look at it again. Review it again, make sure all this stuff makes sense. You guys asked fantastic questions during. Fantastic. Cool? Let's chit chat. You want to take 5 and then do an exam review, or do the exam review right now, then take 5?
Take 5.
Take 5. Let's take 5 then. You got that glazed look, yeah?